Thank you very much also for inviting me, for the nice introduction, and also good morning to everybody. Hope you're all well, safe and healthy. You heard before, and of course, cognitive symptoms are a key symptom in schizophrenia. However, you also have various other symptoms, as you know, hallucinations, flattened affect, reduced speech, as here. And the question is there a deeper layer where there's some commonality? Because much of neuropsychological research, the cognitive symptoms like the thought disturbances have been many neuropsychological functions, cognitive testing, different forms of cognitive testing, but it's not really clear relationship here. And you all probably, and I want to focus your attention on a deeper level. You all know this when you have with the schizophrenic patients.
Are they already speaking now?
Yeah. You have a schizophrenic psychotic patient in front of you and suddenly she or he stops. And again. So that's what you call thought blocks or thought disorder. The question, maybe this is not primarily a cognitive deficit, but maybe there's a deeper deficit, that it is a temporal deficit, that your temporal continuity of your psychological and ultimately neuronal activity is interrupted. And that affects your thought. So that's the key idea of this talk, and maybe this little strange title here, temporal discontinuity in experience and in brain. And I'm very intentionally here focused on experience, first person phenomenology in brain. And given the phenomenological context, well, let me just share the next slide. I want to point out to a deeper level of brain and experience beyond the surface of the symptoms. Yeah, so what is hidden beneath? And that will lead us to time, dynamic, like here. And the key assumption of my talk, and that shares Minkowski, I will develop that a little bit earlier, this is an earlier phenomenologist, beginning of 20th century, that he said, the schizophrenic lack the contact with the dynamic or vital contact with reality. It's like a surfer who cannot adapt to the waves. That's exactly, he cannot surf on the waves because she or he cannot synchronize or align with the waves. That's why I have this way. So where is this coming from? So I want to show you that maybe also cognitive deficits, what we heard of, might have a temporal basis. So I show you some different lines of evidence here. Of course, obviously, as a selection. First, I want to go a little bit into the phenomenological background, the first person experience, because that's for me the starting point. So in that sense, I'm very much a phenomenologist. Second, then I will show you some empirical data on self, time, and brain, some EEG data. And then I will show you both fMRI, EEG data, which really show that the relationship between internally or externally oriented cognition, self versus the world, is really altered in these patients. Main hypothesis, main background framing here is that there's really a temporal discontinuity, the flow of your experience and the flow of your neuronal activity are abnormal in these patients. So basically, temporal continuity is something that is shared between the neuronal and the experiential states. I call this, I will come back to that at the end, a common currency, a shared feature between the neuronal and mental level. So let me develop a little bit. So the background motivation of all my work is really trying to get to a deeper level. So you know this picture, this has been often for conscious, unconscious, in the context of Freud, psychoanalysis, but it very well applies also to schizophrenia, because often what we do is really here, we operate at the surface. Yeah, that's what is conscious, the symptoms, cognitive functions, attention, working memory, and even many of the imaging methods really, in a way, just cover the surface here. However, we really need to go to a deeper layer. And this is a paradigmatic example that it's beautiful work. Is Eugen Minkowski is a French psychopathologist at the beginning of the 20th century. And so he assumed what he called sort of a trouble générateur. He was a French, and it's basically a generative disorder. So let's compare this, for instance, to the pancreas insulin deficit is a generative disorder for glucose deficit at the surface and then the various kinds of diabetes symptoms. So the question is, what is this deeper layer? Let me go back here, next slide. So, and he described it very nice. He said, the schizophrenia, remember my picture, my image of the surfer who cannot synchronize a line with the waves, hence surf on the wave. That's a schizophrenic lack the dynamic contact, because you need to be very flexible because the wave continuously changes, so the surfer needs to continuously adapt. And the schizophrenic patients lack that. And you can see that when they dance, when they're in music therapy, in contact with others. So, and he speaks of a temporal desynchronization from the environment and a disrupted time-space experience. So now I take this very seriously. So I take first, what is this time-space experience in the experience itself? And then maybe an analogous feature in the temporal desynchronization you can find on the level of the brain, on the neuronal activity. So let me start with the experience. A colleague of mine, who's also a PhD student of mine, Dr. Gonsalves, and we developed a scale for space and time experience in psychosis, STEP. You have a lot of beautiful qualitative description, Thomas Fuchs and others in more recent literature. Stangelini has semi-qualitative scales, but you really lack a quantitative scale of time and space experience. And that's exactly what we develop, and also for space. Yeah. So in the basis of the scale, he will present it tomorrow in the meeting in more detail at noon, your time, midnight Canadian time. He will present it in more detail. It's called STEP. And base is really on the based on Minkowski. That's it. Lack of vital contact with reality manifest in different forms of time and space experience. So here you see the different items, and he will present more. And we did this in psychotic patients, affective patients, and healthy control. And you can really see that certain items here, this is, for instance, temporal fragmentation, that you do no longer experience flow of time. That is highly significant, much higher in the psychotic group than the affective and the healthy group. So he will present more of that, and these data really support the assumption, and I think it's a quantification of abnormal time and space experience, which I think is really one progress in making the phenomenological research more empirical, more quantitative. As I said, more on that tomorrow. The papers in print will come out, and we would be very happy to share also the step to apply it to get larger sample and also to investigate diagnostic specificity. So my focus is now trying to make the link to the brain. And here now I come to self and the brain. And the first thing is, when you remember, we said, Minkowski said, you don't have dynamic vital contact with reality. So you continuously adapt. When you dance with somebody, you follow the other's movement and also the rhythm of the music. Schizophrenics, as you know this, cannot do that. Yeah, they're strange, fragmented, isolated. Yeah, they're not there. So what does this mean in terms of the brain? It means that maybe the brain cannot properly process the incoming input, the incoming events, sequences, melodies, rhythms from the environment. So meaning we would need to search for some kind of measure on the neuronal side, which sort of provides a temporal interface with the environment. Yeah, basically which segments, allows temporal synchronization, segments the environmental event, integrates them, segregates them properly, melody, non-melody, foreground, background, and that basically provides a dynamic adaptive contact interface with the reality. So one such measure is, and it's becoming more clear also in the basic neuroscience, that the brain itself has various time scales. As you know, when you listen to music, you have a multitude of different time scales, and your brain can somehow all process them. It's amazing. So your brain itself has multiple time scales. It's called so-called intrinsical time scales. And what we, in the recent years, also in basic neuroscientific work, really found that these time scales are specific for input processing, not output processing, for input processing, for complex stochastics, complex music, waves. The surfer need many timescales to adapt his surfboard board and his position to the timescales of the environment, and that you sort of have a matching between the timescales of the environment and the timescales of the brain. So this is a review paper which is published in Nature Communication Biology, where we basically really makes a point, suggests different mechanisms for timescales and input processing. So now and here, I don't want to go into detail, you can measure these timescales by what is called the autocorrelation function measure. You measure the degree of correlation of the neuronal activity over the time with itself. And of course, so the more distant from the 0 point, the less correlation. And again, no details. You have sort of a certain hierarchy of the timescales. Primary sensor regions have shorter timescales. Higher order regions like the fault mode network have longer timescales, transmodal region. So the brain itself is hierarchical, and that hierarchy, it seems to match with the external environment. So now the question is, if you have an abnormal vital contact with reality, maybe this is a dynamic contact, that's the timescales in schizophrenia abnormal. And we know that the timescales are in charge for input processing, so meaning abnormal timescales may be indicative of an abnormal contact, input processing, contact with reality. So here, this is the paper which came out last year, which we did together with a group of Josef Parnas, and Kai-Erik Sandstein was the doctoral student at the time. And we had the good opportunity combining the EEG, the timescale, our way of specific analysis of the data with the EASE. Some of you may know it's a phenomenological instrument for the quantification of self-disorders. So that's what we did. The main idea is here, maybe these schizophrenic patients cannot properly integrate different stimuli, because in order to anticipate the next stimulus, you somehow need to integrate the different stimuli. You need to predict the next movement of the wave to adapt your surfboard. You need to predict the next tone. And for that, you need to integrate that prediction with the previous tone. Maybe that temporal integration, which requires temporal continuity, is lacking in schizophrenia. So main idea, and we did this, we measured the intrinsic neural timescales, the autocorrelation window, remember this correlation with itself of the signal. Then we had a paradigm, particular for self-processing. I will show that. And then we had on the phenomenological level, the EASE, the assessment of the basic self-disorder from a phenomenological point of view. And then, of course, we also did the punch for positive, negative symptoms. So this is a paradigm. It's basically a morphing paradigm. You start to see your own self, your own face, and then it's slightly morphed, and you have to basically point when it's no longer your face. So this is really self-relatedness, and you know that in schizophrenic psychotic patients, this is problematic. So, and of course, it requires temporal integration, because if you morph, okay, this is still me. Okay, so I integrate this one with this one. This is still me. Okay, I integrate this one with this one. So, because this is a sequence, this is temporal integration. Oh, this is no longer me. So here I make a temporal segregation. Yeah, so I make what is called a temporal event segmentation. So maybe these temporal processes are abnormal in schizophrenia patients. That's exactly the idea here. And I tell you the data. So what we did here, what is called the autocorrelation window, remember this correlating function. And we did this first doing the task, the enfacement task, which I just showed you. And this is a topographic map, what you did. And this is what you call the autocorrelation window. And here you see the time, the legs, what is called the legs, positive, negative legs. And this is basically the width of your time window here. And you see, for instance, that in schizophrenia here, the red curve, the width of the time window is much larger, meaning it puts everything together, but it cannot properly segregate. So the windows are too long. It's basically, it swallows everything into one. And then, of course, if you have too long windows, you cannot make a proper distinction between these phases, because at some point you need temporal segregation. You need to integrate that. Okay, this is the cut point. But if the temporal cause of your neuronal activity doesn't allow it, basically it just swallows everything into one, and then it puts everything together. And I will come back to that. Keep that in mind, because that's a key point of the understanding. And so we have actually another study, which is in preparation for a publication, where we could really, in a larger data sample, this is 30 subjects, the other data set is now 100, in separate patients, that we could really replicate this too long autocorrelation window in the, this is EEG frequencies from 1 Hertz to 100 Hertz. And here you can see this also here. So here, this is a healthy subject, have a much different autocorrelation window when compared to the schizophrenic patients. And when you do the topographic maps, you see, no surprise, everybody who does EEG in schizophrenia knows this, particularly the frontal cortex. So what is important, they really seem to integrate too much. And remember, this is the paradigm we had. It was about self-other distinction. If the windows are too long, they cannot make this distinction anymore. Meaning there's no distinction between self and other anymore. So then we said, yeah, but how is it? We also measured the resting state. Remember, in the task, we specifically process the self, and in the resting state, of course, yourself should be different. And that's a key point, that from the resting state, they could not change their autocorrelation window from the resting state. So this is a very important thing, and you will see that in the third part of my talk. It will come back. The schizophrenic patients, maybe they may be relatively okay in the resting state, but when they have to process specific inputs, they cannot process them. They cannot change their resting state activity. So that's really a key feature, and we saw this here. You saw here the schizophrenics, they're almost close to zero in the rest task difference, whereas the healthy subjects really change their autocorrelation in response to the external input. So that provides further support to the idea that really there's an abnormal or lack of input processing, and that means that they cannot dynamically adapt their neuronal activity to the changing inputs. Yeah, that's exactly, and I think it comes very close to what Minkowski originally described as a lack of vital, or I like to say dynamic, contact with reality, because the brain's intrinsic dynamic, its time scales, are not reactive to change anymore. Yeah, for the specialist, you see again, here's the main difference, the rest task difference in the prefrontal area. And you can see also here, these are the healthy subjects, these are the power spectral curves fitted, and you see really the diff. So this is resting state, this is task state, and you can really see how it changes. The configuration of the power spectrum changes from rest to task in the healthy subjects, but not, so this is, so this solid line is the resting state, this dotted line is the task, and you really see it really deviates, and slower and faster frequencies. The faster frequencies are more recruited in the task, which is naturally because it requires fast frequencies. And in the schizophrenic patients, you don't see this difference anymore between task and rest. The curves are very much similar. There's no change, particularly in the faster frequencies in the schizophrenic patients. Yeah, so that really seems to be a key point, that they cannot properly process input. And by input, I mean all kinds of input. Not only the sensory input, also the internal bodily input, and also the own mental input. Yeah. And then she said, now, how is this related to the experience? So the virtue of this data set was that we had the phenomenological quantification of the basic self-disorder with the E-scale from the Panas group, because here we, as I said, we collaborated with that group here. And what was very interesting that we here, this is a mediation, it's a moderation model, so that we could really see that the transition, that the relation. So first we found a good correlation of basic self-disorder with generally negative symptoms. This is no surprise, has been shown in previous data. But even more interesting that was mediated by the intrinsic neural timescales, by our autocorrelation, by the neuronal function. So that really suggests a key role for time on the neuronal level in structuring your psychological life, including, I would say, the cognition, like thought blocks. Yeah, maybe the thought blocks, the cognitive disorders, are primary temporal disorder. I will come back to that. Yeah, so that leads me then to the last part of my talk. So if there is abnormal temporal integration, longer temporal windows, no distinction anymore, then you would assume that there's really no distinction between the internal mental life and the external world. Yeah, so that distinction becomes blurred, internally versus externally oriented cognition. So now you might say, so you can, I try to do this here, and this is obviously a balance. We all know this. Sometimes maybe now you find my talk completely boring and your mind drifts more towards your internal thought content. But maybe when I raise my voice, maybe you say, oh, maybe I need to pay attention here. And then you shift more towards the external. Yeah, so it's a balance between internally, externally oriented cognition. And so now the question is, and that is obviously abnormal in schizophrenia, as you all know, because it's more shifted towards the internally oriented cognition. So the question, how can we model that balance in the brain? So I would say that resting state activity, where you don't perform a specific task, is very close to internally oriented cognition. You dwell in your own thoughts and mind, and you don't care. And externally oriented cognition, typical now, when you really listen to me, you follow my hand movements here, and you probably rhythmically align, you synchronize with me, and you try to follow my thoughts. I hope so. Yeah. Yeah. So the question is, so that means maybe it's the relation between resting state and task activities. How much can the schizophrenic change from rest to task? Maybe that's an indicator. So how much she or he can change from internally to externally oriented cognition and back. So, and what we did here, this was done with a colleague in Spain, Javier, very, very clever engineer, who's very interested in schizophrenia and did some fantastic EEG work on that. So what we did here, so basically here, we looked, this is a meta-analysis published this year. We looked for all studies in schizophrenia, EEG, fMRI, that combine both resting state or pre-stimulus analysis plus task. Because we were interested, how much can they change from the pre-stimulus or resting state to the task? Because that's an indirect index of the degree to which they can process external input. And that's an indicator how much they can synchronize or contact with the external reality, Minkowski. And that's ultimately also an indirect index of the balance between internally, externally oriented cognition. And you'll be surprised, there are not many studies, particularly in fMRI, but also not in EEG, who really analyze both pre-stimulus and task. Because people don't think in that way. It's either resting state or task. Yeah, and you usually cancel out the pre-stimulus of the resting state. Good. Here I show you, and the amazing result of these studies, completely different studies, EEG, fMRI, we all found in all studies that you had a decreased rest-task difference. So the schizophrenic patients, the resting state is somewhat normal, somewhat abnormal, but not as clear. But then the rest-task difference is significantly decreased, meaning they cannot properly process the input. They're not responsive. They cannot follow here some, for instance, these movements that you can follow and you know the meaning. But if you cannot follow them, you cannot synchronize with this movement, you have no idea why I'm doing that. So meaning then, if you cannot synchronize with this movement, meaningless. This strange guy is not of what on earth is he doing there? Yeah, so you're puzzled. So here, this is data from my collaborator, from Javier, from the Spanish guy. So here he had different measures topographic coherence-based measures in EEG, and he looked really for the difference from the change from pre-stimulus to resting state and to task activity. And you see the blue is a healthy subject. They really increase their activity, or here they decrease their activity in another measure. And the red line are the schizophrenics. They remain the same. They don't change from pre-stimulus to task. So meaning the input is not really properly processed. Yeah, the brain is not responsive to change, and then it cannot synchronize, align with the input. And that's really, I think, very much closely resembling the original phenomenological description by Minkowski. As I said, more on Minkowski also tomorrow with my Portuguese collaborator, Dr. Gonçalves, because he's really an expert in that. And you see here, again, some other measures, connectivity, complexity, all in each case, schizophrenia doesn't change. The blue curve is healthy. They really change. So, and amazingly, then we looked for different measures. We looked for different ERPs, P100 and P300, N100, and other measures. And in all measures, we could really find that whether the pre-stimulus measures was too low or too high, the red ones are the schizophrenia, it was always that the rest task or pre-stimulus task difference here in red in the schizophrenic was much lower than in schizophrenia. Meaning the brain is no longer responsive to input processing. It cannot change. It's not adaptive anymore. Yeah, and amazing, it was independent of whether the respective measure was too high or too low. So it seems that the schizophrenic, so here when you have sort of an average level of pre-stimulus activity, you operate in an optimal functional level for responsiveness to external input. However, if your pre-stimulus or resting state is somewhat no longer responsive, it cannot much react anymore. So, and that has that really seems to be because this is a meta-analysis across several studies, we found it, others found it. So it's really a very important finding. And you see here the dynamics from pre-stimulus or rest to task is no longer given. So on a more cognitive level, this is probably related that you cannot switch from your internally oriented cognition to be responsive to the external task and the external stimuli, meaning you cannot shift from internally oriented to externally oriented cognition. And I think that comes very close to what you see clinically. Yeah, they're not responsive, they're delayed. You see that too, they're delayed. Yeah, they're inappropriate, they're not context appropriate, they're not adaptive. So we're currently following that up in various other studies, in particular looking for the input processing different input systems. So coming back a couple of slides with conclusion, and then I leave time for the discussion. So I hope I could show that the brain in schizophrenia shows abnormal neuronal timescales, and they no longer seem to react to external input. Yeah, so, and there's other data on phase coherence, others and own, that they really don't synchronize the phase onsets in their brain activity with the rhythm of the external world. So meaning when they hear music, they cannot just simply tap the rhythm as we like to do it, or yeah, so they just don't get the rhythm. You can ask music therapists, they tell you exactly that. So, and I think that comes really close to what Minkowski said. It's a loss of vital or dynamic contact with the reality because your brain can no longer react. Timescales are too long. There is no distinction between internal and external. And that, so there's a primary temporal deficit and also a spatial deficit. You will hear of that more tomorrow. And that shapes yourself. And that in turn, you see here, I come back to this iceberg picture, the psychopathological symptoms. So when I hear a talk about cognitive symptoms, as before, the first thing I would ask, did you measure some temporal features, time experience? And that we may need to treat that therapeutically in order to better treat cognitive symptoms. Maybe we need to treat the deeper level, the time experience and the temporal continuity, temporal segmentation, the time scales, both in experience as well as in the brain. Why do I emphasize that? Because the idea, this is sort of the more conceptual background framing, which we developed over the last years, that really, let's say, time temporal dynamic may be shared by the neuronal level and by the experiential level, by the neuronal level, by the mental level. So in schizophrenia, and usually it's of course temporal continuity, but maybe here there's abnormal, no relation, no synchronization with the environmental content. So a couple of last slides. Does that have consequences? Yes. Here, for instance, we probed for temporal continuity in drawing therapy. This was a Taiwanese student of mine. He's very interested in painting and art therapy. And so we let the subjects draw. And the idea is, and we measured the drawing process, the temporal continuity of the drawing process. And when you have too much temporal continuity inside, temporal integrations, the longer windows, you expect that when they have to do something as external, they do it shorter because it's a balance. If internal is too much, external is not enough. And that's exactly what you see. You see the different drawings. I show you here one example. This is a healthy subject, different topics they had to draw, and we basically calculated the temporal continuity, the autocorrelation function of the drawing process itself. And you can see that in schizophrenia, they had much shorter autocorrelation window. It's the same what we applied to the neuronal level, the same measure autocorrelation window of the drawing process. So that's actually a way maybe to monitor therapy, the temporal component in therapy, and then maybe in the next step to really maybe individualize and train the temporal component of, let's say, the autocorrelation window in drawing therapy or music therapy, for instance. So that's what my hope is, that it really has a relationship to the therapy. So this is the second to last slide. The basic idea is really here. We have different layers of experience. We have a very basic layer, generative disorder, Minkowski. That's a spatial temporal feature. That leads to the basic self-disturbance, psychopathological symptoms. So this is really just the tip of the iceberg. Yeah, and this is related to different levels of experience. Here the most basic level is what we like to call the pre-experiential or pre-phenomenal level, because this is almost, you cannot find words for this description. And many patients tell me now, it's hard to describe. For them, it's much easier to draw something or to visualize it with a non-verbal medium. Yeah, and that's, I think, the level we need to grasp. And this is where temporal dynamic spatial experience comes in. That's why we call this, and that the symptoms here are strongly shaped by the spatial temporal level. That's why we speak, and that's why I developed the concept of spatial temporal psychopathology as distinguished from affective or cognitive psychopathology, which are on a higher level. So that's why we like to speak of spatial temporal psychopathology and also correspondingly spatial temporal neuroscience. So I think my time is over. If you want to distill the one main message of my talk, it's time is important in schizophrenia because they cannot properly synchronize with the environmental context. Thank you very much.
Oh, thank you, Georg, for that really stimulating proposal, suggestion of a very innovative perspective. I think it is actually, there's a lot of conferences with, lot of presentation of cognitive dysfunction in schizophrenia, but this is a really new alternative perspective that actually perhaps links much better to psychopathology than the conventional framework for cognitive dysfunction like attention, memory, and so on. So we actually now have about a few minutes, about 10 minutes, that we can actually have some discussion. So is there any question or comment that the audience would like to raise? How do we do that? Do people just speak up? So it would be nice if you show your video and briefly say who you are, and then if you can make comments or ask questions. Or you can type something on the chat box. So while we're waiting for the audience, maybe I can start off with some discussion. So now in the more sort of conventional schizophrenia cognitive research paradigms, for many years, people have been talking about a failure in psychosis patient to integrate context into the current information processing. It sounds like there may be something to do with this framework of spatial temporal desynchronization that Georg, you are talking about. How do you relate the two fields of research?
Yeah, I think that's very, very close, because what is here addressed by context is basically the input processing in my case, that you cannot properly change from rest to task. You're not adaptive to the context. You cannot synchronize, you cannot align. The extension of that is that we link that to temporal basis, temporal desynchronization. And that temporal desynchronization, as my hope is both manifest on the neural level of the brain and on the mental level of experience. And as a third layer, if you want to say so, it structures or destructures your cognition. So your thought content also become temporally desynchronized from each other. That's what I mean by the shared common currency between the neuronal and the mental and the symptom level. And that our thought has a certain, let's say, mental dynamic. Your thought content changes. You have another paper in revision on that your thought content changes, fluctuate between internally, externally oriented. Yeah. And that fluctuation is no longer given in that sense in schizophrenia, for instance. Yeah.
Okay, so if there's don't see other people saying so, I will take advantage of this. Okay, so to follow up on that. So in that response, I take it as indicating the spatial temporal structure is perhaps a bit even more basic than the usual context we think of, with psychological content and so on. Is a sort of basic experience or structure through which we experience time and space, that basic structure that is affected. And towards that sort of very basic processes, I remember some very early work in schizophrenia research. Of course, everybody knows that the simple reaction time in schizophrenia, there is a slowing of the simple reaction time, and not only a slowing, but more dispersion. The reaction time become more dispersed. So this remind me of the data that Georg, you are showing with this autocorrelation, that there is a more spread of the signals. And I wonder whether this could well be related. And I think actually the P300 early data also show the same thing, that there is a slowing, but more spread. So that is not just a motor response problem, it is a perceptual problem as well. So I wonder whether you can comment a little bit more on those.
Yeah, very, very, very good point. I really like this. So it's slowed, but it's also more variable. It's, as you said, it's more spread. So now we look for intra and inter-subject variance. So how much does the autocorrelation window change over time in the course of time? And in schizophrenia, you see abnormal variance. So apparently it really seems that your internal signals are very unstable and they don't follow a certain pattern anymore. They're more random. Yeah. And that is indeed support that complexity and entropy of these signals are higher. So, and we have data in the pipeline that we indeed show that the autocorrelation window is much more variable and much more random in schizophrenia. So now imagine if you have a random autocorrelation window, yeah, you never know how now you segment and how you process the music. So you put parts of a melody together with something else. So, and then you get a mishmash. Yeah, it's very interesting that you say the same thing in the earlier data. I wasn't aware of that. So we really look now for intra and inter-subject variance of the signals, yeah, which is usually considered as noise. Yes, but it's probably part of the pathophysiological process.
Okay, we still have a few minutes, so if there's no any questions. Oh, there is something in the chat box. Let me see. Okay, there is a question from Suri. Suri, are you there? Can you actually have a voice? You can actually ask the question yourself if we pop up. Otherwise, I'll read out the question for you. No? No. Oh, apparently people don't have voices, so I will read out the question. So, Suri, actually, Suri, academic from my colleague, actually, from University of Hong Kong. So she asked, is this temporal spatial difficulty specific to schizophrenia or also for other conditions?
Yeah, good question. Very good question. So space and time can change in different ways. And the idea is that different disorders have different kinds of changes of time and space. So for instance, here in schizophrenia, you have you're lacking temporal continuity, you have temporal fragmentation, your different time points in experience in the brain, also in space, are no longer properly connected anymore. Yeah. So they no longer stand in a systematic relationship to each other. And then see, as Eric said before, they fluctuate, they go here, they go there, and they're more random, there's more chaos in that sense, more entropy, yeah, more disorder, more irregularity. In depression, we build up the hypothesis that here it's not sort of this randomness of time and space, different time point, it's that time is too slow. Yeah, that time, and you know that we had a paper in 2018 in bipolar where we had a phenomenal and neuronal measures, too slow, too fast. That was the title of the paper, 2018 in Schizophrenia Bulletin. So, and we really pursue this now, that basically the time is too slow. And you see this, that they cannot react to faster stimuli, but they react well to slower stimuli. The activity, we had a paper last year, Scalabrini had shifted towards the global signal topography in fMRI, shifted towards the DMN, default mode network, which is by default slower in its activity than the primary sensory regions. And that's exactly what these patients also report. Abnormal slow, and the external environment is too fast for them. And of course, in mania, I don't need to tell you, it's the opposite. They're too fast, and we are, the presumably healthy people, are too slow for the manic patients. And of course, what happens? You become impatient and angry. Why? Be faster. Yeah. So, and we try to build that up for different disorders, different generative disorders of space and time. That's what I call spatial temporal psychopathology, and I hope we can make it specific, because I think cognitive psychology has good results, but could not really show specificity for the disorder. You have executive deficits similar in schizophrenia, in depression. Yeah. So my hope is that with the spatial temporal, that we have different disease-specific generative disorders, to use Minkowski, of specific space and time changes on both experiential and neuronal level. Yeah, and that's what we are trying to develop. So we do this for depression, anxiety disorder, and schizophrenia, and you can already imagine that's a lot of stuff. Yeah, but that's very important, because my hope is that this spatial temporal psychopathology is not just an intellectual figment of Dr. Northoff, but it's really used for diagnosis and differential diagnosis. Yeah, and only if it provides a differential diagnosis and makes a better prediction in that, then it's valid and then it's right. And I think that's a problem. Despite all progress, we do not have yet a clinical marker from the traditional psychology, and also not from the brain imaging. Yeah, let's face it, let's be honest, nothing has entered clinical practice. And that's what my hope is. So as intellectual and abstract and strange as it sounds, we really want to make this differential diagnosis. Yeah, and we now combine, I presented the brain part today. You will see Dr. Gonsalves, Felipe tomorrow will present some of the time and space experience part. And ultimately, we want to look for similar, let's say, the premonition was a time point from Kimura, early Japanese phenomenologist, pointed out premonition in the future. And then maybe we have lack of prediction on the neuronal activity, that from time point to time point, you have high entropy and there's no prediction. The neuronal activity is more random. That's sort of the idea where we want it. And that's specific for schizophrenia. The depression probably predict too much. Yeah, it's probably maybe the opposite, but I need to be careful here.
Okay, thank you, Georg. And that's really highlighted the potential of this approach, in contrast to the conventional cognitive approach in its link to psychopathology and hopefully with category of disorders too. And it makes a lot of sense that the spatial temporal structure, for example, may have a promise to distinguish between mood disorder and schizophrenia. So we look forward to updating in the future about your research and the research in this area from your group. Okay, let's thank Georg again for this very stimulating and cutting edge sharing of his work. Now we have a little break, tea break of I think 15 minutes, and we will resume in 10:45 if I'm correct. Right, you have your program. Yes, 10:45 we'll have the sessions. So thank you again, Georg. Thank you.
Thank you very much. Yeah.